You are not a pre-programmed code for disease. Yes, you have genes, but those genes are like a switchboard. They can be turned on or turned off through epigenetics. Who's sitting at the switchboard flipping the switches?
Welcome to Commune. We are on a mission to inspire, heal, and bring the world closer together.
This whole journey that I'm on it feels so bizarre to me because my mission through all of this was quite simply to become a medical doctor. And I really didn't have any plan to be an author in any way. This was not the goal until all of a sudden it kind of became, a possibility. And to know that a person like you could pick up my book and hear that message that I'm trying to deliver to the world and then apply it to their own life and reap those rewards where it empowers you to better health on so many levels. It's not just weight loss. It's so much more than that. That to me is like just going back to the original sort of version of the mission that started when I was 16 years old. It's a dream come true. As a medical doctor, what more could I possibly want than what you're describing to me? And if you were my patient sitting in a clinic, I would be jumping up and down with joy and we would have a big hug.
Yeah.
Well, but now I'm just meeting you for the first time and you read my book. It's kind of cool.
Yeah. And, everyone, well, it's funny because when you write a book and it's just sitting on your desk there, it's your book. But when you release it unto the world, what was your book becomes hundreds of thousands or millions of people's books because everyone's bringing their own story to your ideas. And it becomes incredibly protean in a way. It's sort of like very much kind of in line with the Hindu tradition of like there's the Brahman and there's all the kind of modifications of the Brahman playing itself out as it. And so I think that, for me, I wasn't sick per se,
Right.
But I suppose the lesson is you don't have to be sick to get better. Like the book wasn't treating any particular symptoms in me, although certainly like I had fatigue and I was brain fogged and was carrying around maybe a little bit extra weight and I wasn't sleeping well, et cetera. So there's plenty of things that I could have pointed to. But really what it helped me understand was to kind of apply knowledge and mechanism to my own body, to my own self, such that I could actually instantiate better decisions. And really live an examined life, not just from sort of a kind of metaphysical or psychological perspective, but also from a very physiological perspective. And it's just opened up so much knowledge and so much curiosity. And of course, like the more fire you bring to the darkness, the more darkness is revealed. So I'm just at the beginning of my journey with it, but you've helped pave the beginning of it. So thanks again.
Well, I kind of feel like, to be honest with you, part of what's been happening in science that is so exciting that perhaps we will be digging into during this conversation is that we're filling in the puzzle pieces, and now we're starting to see the bigger picture. And what used to be studies from the 1990s that said, if you eat this way, you will have less heart disease, or you will have less cancer, or you will lose weight. And, the problem is as humans, like that doesn't actually get us really super motivated. It's a little too distant and obscure for us to really rationalize and wrap our minds around. But when you start to fill in the puzzle pieces, and I think that's what we're doing with the science of the gut microbiome, that's really, revolutionizing the way that we think about this world that we live in, including our own biology. When you start to fill in those puzzle pieces, then you can see this and you see it and you go, wow, like I'm a visual creature. And now it's starting to come together for me and it's making sense. And now I want more of that. And I kind of feel like that's a little bit of what I'm hearing from you, Jeff, to be honest with you, is that you had heard, I'm sure, from your grandma that eating plants was good for you. But now understanding more about the actual science of what's happening with your body and why you should eat this way, the why then motivates you to start to push towards doing it. And then that's how we get motivated to make change, which frankly isn't easy.
Yeah, no, I totally agree. I feel like I'm that annoying little kid that just keeps asking the question why. When exactly, your parents say like, eat your broccoli, but why? And then there's some sort of vague answer. Well, it's nutritious, but why is it nutritious? Well, we're actually starting to unpack the true reasons, why, and then for me, and just as this is the way my brain works, when I understand mechanism, it is so much easier to then reify because I actually understand it. And it also gives you a deeper knowledge of how things are working and not just like some commandment of like, you must do this or you must do that. So anyways, there's so much I want to talk to you about. And also I'm excited to address the new cookbook that you've got coming in mid-May, on May 17th, the Fiber Fueled Cookbook, which in some ways springboards out of Fiber Fueled, of course. And I've gotten into some of the both actionable and delicious recipes in that book. But it's more than just a cookbook. It's really just it's a blueprint to address all sorts of food intolerances and really just a guide to living a more animated and thriving life. So I'm psyched to get into that. But I think for the sake of some listeners that are early on their journey, I think it would be wise to scaffold this discussion in some basic concepts and definitions that are really central to your work as a whole. And so I'll start with this, and this has a slight metaphysical ring to it, but you write that as individuals, we actually live as a superorganism. What do you mean by that?
Well, it's interesting. We have been raised to view ourselves as autonomous, solitary creatures. Mm-hmm. Yet we are never alone. And there's never been a human throughout the entirety of human history, 3 million plus years of human history, that was ever alone. We were never sterile. We have these invisible microorganisms that are a very important part of who we actually are. And we call that the microbiome. And the microbiome is our term, which is referring to basically this entire community that covers all external facing structures, Jeff, on the human body. So like, for example, my skin is just, you can't see them right now. You would need to pull out a microscope, but my skin right now is completely covered with microbes. I'm going to hold my thumb up for people who are watching the video right now. And what you're seeing right there is the imprint of my thumb. And right there are as many microbes as there are people in the UK, just in that single location. So they're in our nose, they're in our mouth, they're inside a woman's vagina, but they are most concentrated inside our large intestine, which is called our colon. And this concentrated community, there's 38 trillion of them there. Now, this number is quite challenging for us to wrap our minds around because, gosh, you take like the entire population of the planet and it's 8 billion. Yeah. And that is a very small fraction. That's less than 1,000th of what we're talking about here. And so 38 trillion, it would be us taking all the stars in the sky. So our universe has about 100 billion stars. And you could place that into your gut microbiome 100 times, right? Place that into your colon. And you still are not meeting the number of microbes that exist as a part of our gut microbiome. And so it's quite incredible. And when we look at how we became who we are today, many of us like to look back at evolutionary concepts. What is a human? What am I? And when we ask these questions and we talk about evolution, the part of the equation that we've been missing this entire time that we need to talk about are these microbes. They were a part of every single day of human evolution from the beginning up to where we are today. And through this process, Jeff, I can tell you this, based upon the science, if you look at this, we very clearly grew to trust them in a very powerful way, because we basically outsourced some of the most important tasks for human health to this community of microbes that they're not even human. They're not even formally part of your body. Yet our physiology is completely dependent on them. So what am I referring to? Well, first, digestion, breaking down and processing and accessing nutrients. That's literally life. We don't have life without access to nutrients. Our immune system, 70% of our immune system lives inside our gut in close proximity to the 38 trillion microbes, where literally if you took a single hair follicle, a single hair off of our head, you would need to actually shave it to be a fraction of what that is. And that's the amount of space that separates 38 trillion microbes from 70% of your immune system, literally right now as we're sitting here. Our metabolism, which is the engine, that makes us run, makes us move. We could talk about how blood pressure and cholesterol and weight balance and insulin sensitivity versus insulin resistance. These things are all, in a way, regulated by these gut microbes. They affect our hormonal balance. They affect our mood, our brain health. And when we talk about genetics, it's an interesting thing because I grew up in a generation where the idea of genetics was extremely promising. Hey, if we could figure out the genetic code, we can cure cancer. That was the narrative of the 90s. And we did figure out the genetic code. Francis Collins, who recently retired, he was one of the ones to do it. But we still have cancer. We still have heart disease. And part of the reason why is because, number one, and I actually consider this a major source of empowerment, you are not a pre-programmed code for disease. Yes, you have genes, but those genes are like a switchboard. They can be turned on or turned off through epigenetics. Who's sitting at the switchboard flipping the switches? Our gut microbes. And when we think about the number 38 trillion, to frame this is clearly more than 50% of your cells. You are less than 50% human. There is no question. And if we look at the cells that I really consider to be the cells, they have a nucleus and they have a Golgi complex and endoplasmic reticulum, those organelles. When we talk about those cells, you are less than 10% human. But if we look at the genetic code, when it comes to our genes, you are only 0.5% human. 99.5% of your genetic code comes from this microbiome. So, Jeff, the story is that living inside of us is this ecosystem. It is an ecosystem, just like the Amazon rainforest, just like the Great Barrier Reef. And that ecosystem turns out to be, I'm being sincere when I say this, the most important part of human health. And it's not even human.
That's an incredible statement, that human health is not dependent on the human cell. That is and it's a real paradigm shift, because we have kind of excoriated bacteria since the time of germ theory, basically. And we can talk about all the things that we did over the course of the 20th century in a war against bacteria, from obviously in our bodies with the overprescription and overadministration of antibiotics, but also in our soil, et cetera. But then at the same time, sort of sanctifying the kind of Watson and Crick paradigm of genetics, where we are coded for a particular fate. And I think what we are just discovering right now is that we live in this mutually interdependent ecosystem with our microbes. I mean, one of the fascinating things that you point out in your book is that one of the manifestations of this coevolution is that we've outsourced the primary digestion of carbohydrates to our bacteria, right? Because they're the ones actually creating most of the enzymes to digest carbohydrates. And we only have 17. When I read that in the book, I was like, oh my God, this is truly a co-evolution. And we've we've developed all these adaptive mechanisms for a reason. But right. What we've seen with this kind of efflorescence of chronic disease is in many ways, culture is now outpacing evolution. And certainly that's true in terms of our lifestyle, what we eat, kind of the nature of how we are mostly sedentary, et cetera. And it's just, and I think where you are is right on this bleeding edge of discovery, where that's so empowering, and that's saying that we have a lot more agency over our own physiological and psychological destiny than we thought we might have. So that's just amazing.
Well, I think step one through all of this is to have an awareness that this is even something that exists. And everything that you're describing, Jeff, you're talking about germ theory. So germ theory is something that you and I both grew up just accepting to be true, that, bacteria cause harm, that they cause infections like pneumonia or whatever that may be. But if you actually think about this idea, it's actually radically fresh in terms of, human history. It wasn't that long ago. The Civil War was taking place in the United States, and we knew nothing about microbes. Yeah. And Jeff, I don't know about you, but I'm just going to come clean on this. I've started to turn into my father, and I'm getting into things like reading history books. So, I'm reading the history of the Civil War right now, and there's these things that are striking me that stand out. For example, the soldiers were smart enough to know that you don't go to the hospital. And they couldn't explain why. They didn't know, but they knew that when people went to the hospital, bad things happened and they died. Germ theory had not been invented yet. Louis Pasteur really is the one who accelerated and brought forward this concept of germ theory. And that was in France, and that was taking place around the same time that the Civil War was occurring in the United States. So during the Civil War, people didn't know, but here's what was happening. People weren't dying just of gunshot wounds. Most of them who were dying of infections after gunshot wounds. Stonewall Jackson, he survived the gunshot wounds that he received, but he died of an infection 2 weeks later. So, it makes sense that if you look at what played out after that, at the turn of the 20th century, around 1900, our top 3 causes of death were all infections. Could you die from heart disease or cancer? Of course you could, but that was not the major threat to human life. And the biggest breakthrough in the history of medicine, to me, is very clear. It is World War II and our discovery of penicillin.
Yeah.
And suddenly we have a way to take the top causes of death and make them wash away. Can you imagine being a doctor at this period of time in history of medicine, where prior to this, you don't really have powerful tools to fix people, and people are you're just passively watching them go. And all of a sudden, here comes this complete lightsaber where you can just slash down that infection like it's nothing and save a person's life. And it attracted us, Jeff, where we said, gosh, this is so powerful. We need more of that. And so we doubled, tripled, quadrupled down on pharmaceutical development. And we empowered the pharmaceutical industry, and we basically asked them to become what we are seeing today. But in this process of being seduced by the power of a pill or the power of a procedure, we completely lost sight of who we actually are. And I think part of it is that, again, the puzzle pieces were missing, and we didn't have that complete picture to understand. We knew that we pooped. We knew that we passed gas. Why would anyone be interested in that kind of stuff? I have no clue, right? That's the least valuable thing that exists on the planet. And yet, how things have changed, where since roughly 2005, 2006, we developed the laboratory techniques that we needed to start to study these invisible microbes. And we also developed the power of the computers that we needed, that if you took, good computers from the 1990s, they quite simply weren't able to keep up with what we needed them to do. Because, like I said, you have 200 times more genetic code in a bowel movement than you do in your own body as a human. So that's a tremendous amount of information that you will find in a human bowel movement. And we needed more powerful computers to catch up and get on top of this. And so, here we are. And it's like you said, Jeff, we've waged a war on these microbes, and it makes sense, right? People were top 3 causes of death 100 years ago were infections. It makes sense. But like everything, there's a point at which we take it too far. And it's time for the pendulum to swing back the other way, and for us to embrace our true natural self. And part of the way that we accomplish that is by having a vision to these microbes that may be invisible to our eye. But let's allow the science to share with us what we would see if we were to have a microscope and take a deeper look.
Yeah, fascinating. An interesting point about World War II, and I'm not sure if this is apocryphal or not, but I've heard that Nazi Germany and Hitler did not have access to penicillin during World War II, and of course Fleming and had discovered it in the late 1920s, but I don't think it was really available until maybe a decade later. But the United States obviously could avail themselves of penicillin, and I've heard some people make the argument that that was one of the contributing reasons to victory. But anyways, I think it's an interesting side point of history. So I think you've established that we've got about 38 trillion bacteria in our gut. They all have their own DNA. About how many species, more or less, would you say? And I know that this would vary on an individual basis, but if you have a healthy gut, what does the kind of plethora look like?
Well, we're talking mostly on the order of hundreds, and so what we know is this. First of all, it's important to point out that diversity of species, meaning the different varieties of species, is actually a measure of health for the gut. And this is actually a concept that transcends the gut microbiome and actually is applicable to all ecosystems. Any sort of biologist will tell you, if you look at, for example, we could look at the Amazon rainforest, the diversity of species that exist within that rainforest creates resilience, so that when bad things happen, the rainforest is resilient and able to basically take a punch in the face and shake it off and keep moving on. A quick example, I don't like snakes. They absolutely terrify me. When I was a kid, I was fishing, and a water snake, it was non-poisonous, but a water snake chased me, and I was 3 years old. And so from the age of 3 up until I don't even know when, I swear it was like when I was a teenager, I used to have recurrent nightmares that snakes were in my bed with me. All right, so you imagine how I feel about them. Yet I don't want us to eliminate all the snakes in the rainforest, because the problem is that snakes are there with a purpose. And if we eliminate the snakes, the other animals quite simply are not capable of stepping in and fulfilling the job that the snakes do. No one else can do it as well as the snakes. And that creates a ripple effect where things fall out of balance. Now, because there's no snakes, we get an excess of perhaps rats or small rodents, and those small rodents start to eat more of what they eat. And now you see a downstream cascading event where we have created instability throughout the ecosystem. This is exactly the way that it works within our gut microbiome. Our gut microbiome thrives on diversity, variety. We know that a person with a healthy gut microbiome has, somewhere on the order of 700, 800, 1,000 different species. Now, it's interesting because when we look at native cultures, for example, if you were to go and study the Hadza, which is a hunter-gatherer tribe that exists in Tanzania, that is rapidly dwindling because unfortunately the young members of the tribe are there are people who come to visit them and they see there's a cell phone and they go, "What's that cell phone? Oh, that's kind of cool. I want to be a part of that." And they leave the tribe. But nonetheless, they're living a very traditional lifestyle. It's actually agricultural in the sense that they are hunters and gatherers. And when we look at them, we find 1,500, 1,600 species. So in the United States, we already are at a deficiency relative to where we probably were in the past. And they've done some interesting studies, Jeff, where, I guess before I even mention this, let me just say that this is not just like conceptual, that diversity is relevant, that if you look at the diseases that manifest in association with injury to the gut microbiome, which the word that we use for injury or disturbance of the microbiome is dysbiosis. If you look at the conditions that exist, it's a loss of species that's present in nearly all of these cases. And so that includes obesity and, ulcerative colitis, Crohn's disease, rheumatoid arthritis, asthma, seasonal allergies, endometriosis, PCOS. I could keep going. So depression, anxiety, all these different conditions. Well, so diversity is important. Well, they have done studies where they look at people who leave third world countries and they move to the United States. And within just a period of months, there already is a substantial loss of diversity that takes place. And I think that this, to me, this goes beyond nutrition. We will talk about nutrition. But I think it's very important for people to understand that this is not just what we eat. This is actually, our gut microbiome is a reflection of the complete environment in which we exist as humans. And by complete environment, I mean not just literally your house, although your house is part of it, right? And the people that you cohabitate with, and whether or not you have pets, but also what's your sleep pattern like? Are you getting enough rest? Are you moving your body, staying physically active? And perhaps the most underrated and important thing, what's your level of stress? Is there something unsettled that's causing trouble for you? So this diversity within the gut microbiome ends up being sort of this critical piece that we can see. You can increase your diversity by making the right steps. You can also reduce the diversity by negatively affecting the environment in which you live. And then we expect you are predisposing yourself to the development of disease as a result of that.
Yeah, fascinating. You bring up that notion of trophic cascade, in the Amazon, and there's a great example in Yellowstone with the extirpation of the wolves, for example. When they started killing the wolves in Yellowstone, all of the other flora and fauna started to disappear. And again, this speaks to the, you can apply that metaphor, directly to your gut. And, if you start to lose species of bifidobacteria or lactobacilli, or, you're going to stop the production of, these SCFAs, which we'll get into, that can have a really detrimental impact on a whole variety of systems in your body. So let's do just a little more. Go for it. Yeah.
Well, I just want to comment real quick that, first of all, these microbes are as unique as you and I are.
Mhm.
And there are things that I do well, and there are things that you do well. And when you pair us up as a team, we're better together, right? That's like the story of humanity. We're always better working as a collective whole than we are by our individual selves. I sure as heck am better because my wife keeps me in check and helps me to be a better man. But even beyond that, just quite simple stories that we tell. What would the Avengers be if it was just one of them, right? What if it was just Spider-Man? Spider-Man wouldn't be able to win the end game, right? What if we had 10 Spider-Mans? Well, all 10 Spider-Mans have the exact same skills. They don't complement each other. So you have more of the same thing, but we need Iron Man. Sometimes we need the Hulk, right? And that's what's happening in our gut microbiome is that every single one of these microbes, they're not the same thing. They have different skills and different personalities and different dietary preferences. And so you can think of them as little miniature versions of us. And just Jeff, as an aside, I can't help but comment on the wolves because it's a heartbreaking thing. I was out in Wyoming with my wife in the summer of 2021. It's a beautiful place. And the problem is, like, I don't care how many acres Yellowstone is. These are wild animals, and these wild animals are going to like leave the confines of the park. And then we, the humans, create problems. And because we don't allow the animal to do what it naturally does, which is hunt. And so in a way, we are the disruptors of that ecosystem. And I think about, you're talking about metaphysical before. If you kind of think about it, there's layers of the exact same patterns that exist throughout our universe. And it's just a matter of, are you zooming in or are you zooming out?
Right.
So our microbes, like everything that exists on our planet that's alive, it either has a microbiome, like you and I, we have microbiomes, and plants have microbiomes and other animals have microbiomes, or it's a part, or it is the microbiome. And I sometimes feel like, okay, so we could zoom in and see these microbes and they would look just like us. They're alive, right? But when we zoom out, we don't see them. We see us. But then when we zoom out further, we see this planet. And you don't really see the humans that are inhabiting the planet. Yet the humans, sometimes I feel like, we are the dysbiosis on this planet. So,
yeah, that's a great image. Yeah, Alan Watts uses a similar metaphor. He's like, when you are looking at a newspaper, for example, under a microscope, an image looks just like dots with space around it. But then when you zoom out, oh, well, there's an image of a woman on a newspaper. And of course, when we got those, Neil deGrasse Tyson speaks so eloquently about this, but when we got those photos back from the Apollo mission in 1969 that showed kind of this luminous, radiant orb of the Earth, it really captivated people for the very reason that you allude to, because for once we saw something in its whole and not dismembered in its component parts in a way we remembered it literally. And of course, we tend to trudge through life on a quotidian basis, feeling like a separate self, in a separate external world, kind of cleaved from it. And I think, when we start examining systems, like you do, and that delusion begins to, be unveiled. We would never look at the microbes in our gut and think of them as separate selves. We'd think of them as part of a whole organism, and then we are part of a whole organism. And anyways, I think that there is
we are a superorganism, right? We are a superorganism, and when you think about so much of what brings us, like makes us human and brings great joy, part of it is interpersonal connection. And the gut microbes are actually a part of every single part of that. If I reach out and I touch my wife's hand, we're sharing microbes. If I see you and I give you a big high five, Jeff, we're sharing microbes. If I give my wife a kiss, like, why do we kiss? They actually have found that people share about 100 million microbes when they kiss, and that the motivation may be actually an experiment to see if there's compatibility among the microbes. See if it makes sense.
It's amazing. Even body odor works that way, is that sweat, I don't think, is actually inherently malodorous. It's the bacteria digestion of the sweat. I read an article in the New York Times about, I think it's Lactobacillus reuteri, particularly, that has that clusters in the armpits or in areas that sweat is prevalent, and creates that special musk that you might or might not be attracted to. So it may be just an adaptive advantage that's hooking people up with each other. And who knows? But it's fascinating. I wanted to talk a little bit about bacteria and what they eat. And perhaps this is a good moment for you to elucidate the delineation between prebiotics, probiotics, and postbiotics.
I would love to. I think it's a very important concept because people are going to be hearing about this. And, even if you're not hearing it from us, you're going to go to your local store and be shopping, and you're going to be seeing these terms applied to, I've seen them in multiple foods, and now I'm seeing them in cosmetics. And so most of us, I would imagine, have heard of probiotics. Now, probiotics are microbes that have been demonstrated through clinical research to actually have benefits for humans. So it's not just that they're microbes, it's that they're actually good for us as humans. And you could take probiotics as a supplement if you like, but guess what? You have like literally trillions and trillions of microbes. Most of the 38 trillion are probiotics, and they're inside of you right now. And they want to help, and they want to support you, but they are, again, as alive as you and I are, Jeff. And so they require an energy source. Life on this planet requires energy in order to do its job. And what they eat, their preferred food, are the prebiotics, P-R-E. So prebiotics, there are actually 3 main prebiotics. The point is that prebiotics are food or a source of energy for the gut microbes. And as a result, they have health benefits when you consume these specific nutrients. The 3 nutrients that I want to bring forward for today, the first is fiber. So fiber is like the boring stuff that your grandma used to stir into a drink so that she could have a bowel movement. But I'm here to try to radically transform your vision of fiber by the end of listening to this podcast, so that you will see fiber and instead see something that's like completely transforming science and incredibly sexy and exciting. Fiber passes through the intestine and it is unchanged because we lack the enzymes necessary as humans to break down and process fiber. What that means is that fiber will arrive into the colon completely intact, the exact same way that it was when we swallowed it down. And there are the gut microbes, and they are waiting for this arrival, and they get into an absolute feeding frenzy. They are excited because fiber is their preferred food. And they actually have the enzymes. So through a sequence of like timely, synchronized reactions, they will apply their enzymes. Again, I said they have special skills. This is one of them. They will apply their enzymes to break down and process the fiber. And when they do this, the microbes, they grow stronger. We will see them more powerfully represented. They become more capable of doing their job as a result of this, which is, again, to support human health. And that fiber, it doesn't just like go in the mouth and pass out the other end. That fiber actually undergoes transformation that I would describe as magical, like Harry Potter whipping his wand and saying the magic words. And next thing you know, what you have are short chain fatty acids. Short chain fatty acids Jeff, I started medical school in 2002. So I've been in this health space for more than 20 years. And I've never come across anything as powerful from an anti-inflammatory perspective as these short chain fatty acids. What you'll hear about is butyrate most likely, but there's butyrate, acetate, propionate, and they come from the consumption of fiber, prebiotics, meeting the probiotics, the bacteria that live inside you. And what they do is they release the short chain fatty acids, which are the postbiotics. And I'm here to deliver a unique message that I'm guessing most people have never heard before, which is that it's not about the probiotics. And frankly, it's not even about the prebiotics. It's about the postbiotics. But the way that we get the postbiotics, the product of these microbes, letting them work their magic, the way that we get that is by allowing the prebiotics and the probiotics to intersect, and then the magic happens. So a quick comment, Jeff, on the short chain fatty acids. I could literally talk for an hour about them. I'm completely obsessed with them because I feel like this is the part of science that everyone needs to be hearing, where we're fighting one another about trivial concepts and not talking enough about the part that really matters, which is this. The short chain fatty acids will fix and repair a damaged gut. They will help the good guys to grow. They will directly suppress the bad guys. I'm talking about E. coli, Salmonella, Shigella. People have heard of these microbes. They're not good guys. And we can suppress them with short chain fatty acids. We talked about the gut barrier, that single layer of cells that separates the immune system from your gut microbiome. And there's this idea called leaky gut. Well, leaky gut is when the gut barrier is breaking down. We can repair leaky gut. Short chain fatty acids are the way to do it. They actually impair the development of colon cancer, our number 2 cause of cancer death in America. 150,000 people will be diagnosed this year. Short chain fatty acids impair colon cancer through multiple different mechanisms. They actually interact with the immune system. They're signaling molecules. We could talk about the way in which short chain fatty acids appear to be very relevant in our fight against COVID-19. They affect our metabolism, lower our blood pressure, lower our cholesterol, improve our insulin sensitivity. Those 3 cardiac risk factors. So it comes as no surprise that when we look at people who have coronary artery disease and we look under the hood and examine their microbiome, we find less of the microbes that produce short chain fatty acids in people who have coronary artery disease, our number 1 killer. They travel throughout the body. They will affect the blood-brain barrier. They will cross the blood-brain barrier. They will improve the brain, make it more sharp, more focused. The bottom line is that they have healing effects everywhere they go throughout the entire body. The way that we get it is by consuming dietary fiber. And the problem that we have in our society is that if you and I walk out on the street and we find a representative sample of average America, 19 out of 20 people that we interact with will be below the minimal recommended amount of dietary fiber. 95% of people are fiber deficient. This is a huge part of the reason why we have the health issues that we have in 2022. So, and just to close out real quick, Jeff, there's 2 other major sources of prebiotics. One are resistant starches. Resistant starches aren't technically fiber, but for the purposes of your understanding, you might as well consider them dietary fiber because they are the same thing in terms of they produce short chain fatty acids. You'll find that in white potatoes, other starchy foods. You'll find it in green bananas. So they're a good thing. And then the third type of prebiotic are the polyphenols. Polyphenols are the colors. So you see a yellow or a red or a blue or a purple plant, and you know that there's polyphenols. All plants contain polyphenols. Only plants contain polyphenols. If you want them, you have to consume plants. And when we say eat the rainbow, that's just a way for us to say that every single color that exists in the rainbow of plants has its own unique health benefits. So this is where, fiber, resistant starches, polyphenols, you will simply, easily find all 3 in plants, and you will get more variety when you eat more varieties of plants.
Love it. That was a great description. So prebiotics plus probiotics equals these postbiotics, which are sometimes called metabolites. They're sometimes called short-chain fatty acids. The most famously celebrated one is the one you referred to, which is butyrate. And I'd love to spend a little time hovering on short-chain fatty acids, because I agree with you. These things are like the honey hole for human health. And in your book, you do such a good job at clearly enumerating these 5 primary axes for human health. So immunity, metabolism, hormonal balance, cognition. I almost forgot the one that was cognition, ironic, and gene expression. And I think you sort of add an asterisk to number 6, which is fecal health or poop health. But
Right.
So I'd love to pull a couple of those out and talk about the relationship specifically between short chain fatty acids and some of these axes. So immunity, for example, which of course is, such a hot topic on everyone's mind right now. Can you expand a little bit about the relationship between microbes and their postbiotics and immunity and the immune system?
Sure. So first of all, I think it's important, going back to what we were talking about earlier in the show. Again, it's a single layer of cells separating 38 trillion microbes from 70% of your immune system. And this layer of cells is not this big wall. It's like a small rickety fence. And they are communicating with one another. They are in constant contact. And one of the powerful ways that they will communicate with one another is through these short-chain fatty acids. Short-chain fatty acids, when it comes to the immune system, have the ability to recruit a specific type of cell called the T helper cells. And these T helper cells have actually been shown to help to shape and mold the immune system. Because the thing about it, Jeff, is that when it comes to our immune system, you can think of the immune system as basically like your army in the fight against disease. It could be an infection, it could be an injury, it could be cancer. We want our immune system to be targeted and precise and highly effective. What we don't want is our immune system to be sloppy and mistargeting, taking on the wrong battles, blowing up when it doesn't need to blow up, right? Like, we need the exact amount in order to eradicate the threat and get back to being healthy again.
Yeah.
And we actually see this. We actually see this in play. It's a fascinating story, Jeff, that has been unfolding in the last 2 years, looking at the relationship between our diet, the gut microbes, and COVID-19. And when I went on our mutual friend Rich Roll's podcast in June of 2020, I predicted that we would discover that the gut microbiome was going to be the critical piece in explaining why some people get severe COVID-19 and some people barely get the sniffles. Why is that? And I felt that it was likely that we would find that the gut microbiome and fiber were critical to this. And the reason that I felt this way is because if we go back and look at some preclinical animal model data, they did this study, Jeff, where they took a look at mice and they infected them with a respiratory virus. Now, to be clear, this respiratory virus was not COVID-19, but they infected them with a respiratory virus, and then they fed these mice either a high fiber diet or a low fiber diet. And the scientists actually predicted that the mice would do worse on a high fiber diet. And they were shocked when they found the opposite result. because the mice on the high fiber diet lived longer with less disease and better metrics for their lungs and how their lungs were functioning. So they said, well, what's going on here? We have to understand this with more clarity. So they dug deeper, and what they discovered is that on the high fiber diet, the fiber came into contact with the gut microbes of the mouse, and short chain fatty acids were released. And those short chain fatty acids actually traveled through the bloodstream to the lung. And in the lung, helped to recruit the proper cells to fight the respiratory virus, so that the response of the immune system was targeted, was precise, was effective. And these mice, they lived longer as a result of quite simply consuming more fiber. So Jeff, if you had fast forward to January of 2021, there is a paper that's published in Gut, which is the top scientific, one of the top 2 gastroenterology journals on the planet. And what they looked at was the gut microbiome. They're looking under the hood at the gut microbiome in people that had different forms of COVID-19. And they found that, number one, when you get COVID-19, there's a change in the gut microbiome. Number 2, the change continues to exist even after you clear the infection. It's still there for 30 days. Number 3, the change that they were seeing became more pronounced in people that had severe COVID-19. What was the change? It was the absence of short chain fatty acid producing microbes. There were specific microbes that were missing. Now, this is quite interesting. And, and in that moment, I'm like, oh, we're onto something here. But hold up. We need human data. I got to see what happens with real people. Fast forward to just recently, I believe published in December, a new study of frontline healthcare workers. And they're looking at their dietary choices. And they discovered that the healthcare workers that were consuming a plant-based diet were at a 73% reduced likelihood of developing moderate to severe COVID-19. People on a pescatarian diet, because pescatarian, again, is fish plus fruits, vegetables, whole grain, seeds, nuts, and legumes. On a pescatarian diet, 59% reduced likelihood of moderate to severe COVID-19. And quite fascinating, the population that did the worst were the people on a low carb diet. Well, guess what? Fiber is a carb. So if we're going low carb, it's hard to go low carb without reducing your fiber intake unless you're literally a registered dietitian. And so people on a low carb diet were 3.8 times more likely to have moderate to severe COVID-19. It's crazy.
Yeah. So this is fascinating. And, of course, I have wondered along the way here with COVID, just like everybody else, why some people have severe reactions and other people have very mild reactions. And, what is the underlying reason for that? And certainly we've pointed to people with multiple comorbidities, are more likely to severely contract COVID, et cetera. But it would only make sense that people that have greater levels of inflammation and oxidative stress are going to have a more severe reaction to this particular viral disease. And as you pointed out, earlier, one of the reasons why so many of us have chronic inflammation is because of intestinal permeability or leaky gut, that the tight junctions in our epithelial wall in our guts break down, right, often due to poor diet, but there's also a lot of other inputs we could talk about that could erode those tight junctions, and that allows endotoxins to enter the bloodstream, and the vascular system moves that around, and the immune system has an inflammatory response, and that inflammatory response can become chronic. And so your your immune system is agitated. And, one of the other things that I've read is that the microbes in your gut also have this ability to induce kind of T cell differentiation. And one of the aspects of that is the generation of these kind of Tregs, or this part of your immune system that is not about amping up the immune system. It's actually about suppressing the immune system at some times. And so you hear about the cytokine storms, right? Well, to me, I'm not a doctor, but from what I associate with that, well, that's sort of the immune system gone haywire and having a reaction that is that overcompensates because it doesn't have the regulatory components to keep it from overreacting. And so, I'm starting to read like, oh my God, commensal bacteria induces T cell differentiation and upregulates Tregs. And I'm like, the gut must play a significant role. And of course, you're bringing real data to the fore, and it's fascinating.
Well, and effectively what you're describing, Jeff, is that imagine rolling down a steep hill with your car and only having the accelerator. Right. And it's very easy to pick up speed, but it's hard to stop it if you don't have your brake, right? And this is the T regulatory cells are the brake that keep things in check, because everything in life, our immune system, our gut microbiome, the way that we function in our society, it's about balance, right? It's about achieving balance. And when things are out of balance, that's when issues come up, because then it's very easy for these disturbances to cause these types of issues.
Yeah. Let's talk a little bit about metabolism and its relationship to short chain fatty acids. Particularly butyrate seems to have the ability to upregulate insulin sensitivity and address insulin resistance. And I'm sure there's other threads to pull there. So what's the relationship between the microbiome and metabolism?
There's a number of different factors that connect the gut microbiome to our metabolism. Let me start with this. I think one of the things that we don't talk about enough is the sense of satiety or fullness after a meal. Because we sit down to eat, and it's so easy for us with the type of food that we eat. The average American, their diet is 60% ultra-processed foods and 30% animal products. By the way, animal products contain no fiber. There's zero fiber in animal products. So we already know how much is there. And literally only 10% of our calories are coming from plants, fruits, vegetables, whole grains, seeds, nuts, and legumes. And when you consume this diet that is deficient, devoid of fiber, then we are missing out on the opportunity to activate these satiety hormones, which butyrate and the short chain fatty acids play a role in. And as a result, it becomes so easy to overeat, and we all have been there. It's a food hangover, right? You feel great when it's going in your mouth. You're ravenous for it. And then 30 minutes later, you're completely miserable. And you need some sort of pick-me-up to get your energy back. And you pretty much need to lay on the couch and wear a pair of sweatpants and make groaning noises for at least an hour to get past it, right? So we've all been there. And by the way, people should know that my diet 10 years ago was about 5% plant-based. So I can assure you that there is no casting of stones towards anyone in your dietary choices. I just quite simply want to empower you with the information to make better choices and improve your health in the process, feel better. So now Kevin Hall is an NIH metabolism researcher, and he does these interesting studies where he will have research participants enter into a metabolic ward where they basically live in a building, like living on campus, living in a dormitory, basically, living with him, and he will provide the food. And he discovered that when you feed people ultra-processed foods, part of it, I'm sure, is the lack of fiber, but part of it is also the other ways in which these foods are being constructed, where they are hyper-palatable. There is something about the way the foods that are being made. Like, if I am the CEO of a food company, a processed food company, my goal is to make you want to come back tomorrow, or maybe even today, right? I want you to be ravenous for my food. So I actually will do research to figure out how to make that possible. And they do this. It's called the bliss point. The bliss point is the point at which a human being basically needs to have it again. And so the foods are basically constructed to reach our bliss point, and they're simultaneously removing the fiber. And the fiber is the part that activates the satiety. And now here we are, and we have 70% of America is overweight and 40% is obese. And this, to me, is one of the big parts of the story, is that we have leaned so much into these artificial foods that we are creating a metabolism problem. When we speak about cholesterol and insulin resistance, which is basically the underpinning of type 2 diabetes, these are things that actually we're actively researching, Jeff. And I'm involved with a company, a personalized nutrition company called Zoe. And I'm actually just recently became the US medical director for Zoe. The reason that I became involved with them is because the research that they're doing is fascinating, where we are taking a population of people, and like anyone can sign up to do this. And you basically are a citizen scientist where you submit your gut microbiome, your blood lipids, and you wear a continuous glucose monitor. And then you tell us what you're eating through an app. There you go. So Jeff, you have the continuous glucose monitor. So take that and combine it also with blood lipid testing, microbiome testing, and then the food app. And you pull it all together. And we have a ton of information. And as we add more people, if we had 10 people, it would be worthless. But we have 10,000 people, and we're going to be 100,000 or 1,000,000. And now these supercomputers can run complex algorithms to be able to say, Jeff, here is the food in terms of optimizing your metabolism that is best for you.
Yeah.
And so it's a very exciting time that's taking place in nutrition, because we're transitioning from what used to be principles of population norms, right? Where it's like, oh, well, we expect on average a person who eats a plant-based diet to lose 5 pounds. Yet one person will gain 5 pounds and another will lose 20. And how do we rectify that? And how do we identify the proper diet for each individual person? So now the reason I bring this up, Jeff, is because metabolism is what we are studying. And we've looked at this exact question. How much does the gut microbiome play a role, for example, in your blood sugar? How much does the gut microbiome play a role, for example, in your blood lipids after a meal? And these are important factors, because ultimately, if you give me just your blood lipids after a meal and your blood sugar after a meal, I can create inferences on whether or not you're at increased risk for coronary artery disease, our number one cause of death. And what we've discovered is that the gut microbiome is a powerful player in both of these stories. That you could take identical human twins, Jeff, pretend that I have a completely identical twin, and pretend that twin literally has lived with me and consumed the same food. I still would only share 35% of the same microbes. And if you gave us the exact same meal, you would see different blood sugars. You would see different blood lipids. In fact, in the story of the blood lipids, the gut microbiome is so powerful that, believe it or not, it is more important than even the food that you're eating. What I'm saying is that your gut microbiome, in terms of your blood lipids, is more meaningful than whether or not you're eating a hot dog or a salad. That's crazy.
Yeah, that is nuts. I mean, I've read some of the in vivo mouse studies where they transplant the microbiome from an obese mouse, for example, into a thin mouse, and the thin mouse gains weight without even changing its diet. So what explains this? Like, what's going on there? And so as you move upstream and keep asking that question, why? Well, there's got to be something there around around insulin sensitivity, essentially how glucose is being ushered into our cells for energy, and 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 what's the confounding variable there? And so I think as we get more data, and I think it's fascinating what you're doing with Zoe, but as we get more data, I think we're going to just have a lot more answers. And I think you're absolutely right. It's such an exciting time because as individuals, we are getting our own human dashboards. I mean,
Right.
you'd never drive a car without a dashboard, right? And
Right.
it tells you what's going on under the hood, oil pressure and tire pressure and gas gauge and et cetera. And if the red light goes on, well, you take it in and you get it looked at, or
Right.
if you're brave enough, you look at it yourself. And now we're getting dashboards into what's going on under our own hoods. And it is so fascinating and it's so interesting. And, I've been wearing this CGM, a continuous glucose monitor, for about 2 months. And, I was running actually strangely pre-diabetic levels when I first started wearing it, or I was getting spikes that were just abnormal. But then I started to really be able to isolate when and why I was getting those spikes. And, I was reacting to particular kinds of inputs. It was some foods. For me, it was actually the sauna that was strangely producing big spikes. And I finally traced that to dehydration, which was essentially lowering my overall blood volume, which would then spike the concentration of glucose in my blood. But I would have never noticed that or known that had I not been wearing the CGM. So it's really just giving us a lot of transparency into what's going on in our body. It's fascinating.
And Jeff, let me add something for you, since you've been wearing the CGM, and so you have the ability to look at this. One of the studies that we published, it was in, I believe, Nature Metabolism. So one of the studies that we published with Zoe was looking at postprandial glucose and how that correlates to how you feel and then how you eat later on in the day. Right? So now anyone, we can all accept that overeating is problematic. And when we binge on food, this is more likely to cause weight gain. In this study, what we discovered, Jeff, is that there are some people who have what's called a blood sugar dip, where your blood sugar goes up, and it's not just how high it goes, it's actually the crash afterwards. And when it crashes afterwards, you drop your blood sugar down below the baseline of where you started. And when you drop below that baseline, your body interprets this as problematic because the fuel for our brain is actually glucose. So now you feel fatigue. And the other thing that you do is you crave simple carbohydrates. And these people, if you follow them a couple hours further after, so they have a meal, their blood sugar drops, you get the blood sugar dip. And if you follow them a couple meals later, what you're going to see, or not a couple meals later, a couple hours later, what you're going to see is that these people are going to attack food more aggressively with their next meal and overeat as a result of the blood sugar dip that had just taken place. And now their metabolism is out of whack. And once again, you can put this back. This is affected by dietary choices. Blood sugar, without question, is affected by dietary choices. You eat a piece of candy, that's not the same thing as eating a salad. That being said, it also is affected by our gut microbiome. And so there are some people, because of their gut microbiome, who are more prone to this happening. And so now the follow-up question is, how do we shape that microbiome so that the blood sugar dip never takes place? Because now we're having better regulation and balance. And that's the question that we haven't answered yet that we need to work on.
Yeah, fascinating. Yeah, I know, you alluded to hormonal balance and to leptin, I think is what you were also alluding to a little bit in terms of this hormone that governs hunger and appetite. And I assume there's also a ghrelin component to that equation as well, is that there can be a feeling of hunger, even if you really would otherwise be physically sated. So I think that that's interesting. And then there's a whole area of study that connects the microbiome to mood, and other neuromodulators like serotonin and oxytocin. I wonder if you have anything to add there about that.
We know, first of all, that serotonin is the happy hormone. It affects our mood. It affects our energy levels. And in patients who suffer with major depression, or even generalized anxiety disorder, we will treat them with drugs called serotonin reuptake inhibitors that basically boost serotonin levels. 90% of serotonin is produced in the gut. There are over 30 neurotransmitters produced in the gut. Now, the serotonin, just to be clear, the serotonin produced in the gut is not actually the serotonin that's affecting our brain and our mood. It's not crossing the blood-brain barrier. But there are precursors to serotonin, like, for example, 5-HT, that have been shown to be produced in the gut, and they do cross the blood-brain barrier. So there's a number of ways through these neurotransmitters that your gut is talking to your brain is talking to your gut. This is the gut-brain axis and their sort of intertwined relationship. And they've done studies where, for example, Jeff, they will do a randomized controlled trial and they will feed people a high fiber diet and discover improvements in their mood. So we have the food-mood connection that already is being studied. And now, more recently, we have research emerging that is looking at the connection between our microbes and our mood, where what we see in the microbes of people who suffer with major depression is increased inflammatory microbes. So there is an inflammatory component to depression. But at the same time, we also will see a depletion of, here it comes once again, the short chain fatty acid producing microbes.
Yeah.
So the patterns that I'm describing, we're not talking about patterns that are identical. These are different expressions of the same theme. But what we're seeing once again is that these anti-inflammatory short chain fatty acids play a critical role in affecting our mood. Now, Jeff, one of the things that I'm very excited about is I'm actually actively involved in research right now, and we're not yet in a position where I have results. But where we are in science is that we have the food and mood connection. We have the microbe and mood connection. And I'm trying to walk this all the way through from the beginning to the end. So actually using the data that I have available to me, I'm looking at food, microbes, and mood. And let's look at this entire story, and then we can use that information to try to help people.
Yeah, I think you can also pull that all the way out to neurodegenerative disease. I was reading a study published in JAMA on transgenic mice, essentially, that there were some mice that had an abundance of this one particular genus of bacteria. And what they showed was a reduced occurrence or deposition of beta amyloid protein in the brain, which is highly associated with Alzheimer's. So,
yeah,
there seems to be even a relationship between certain bacteria and some of these neurodegenerative diseases, which are, among the biggest killers now.
Yeah, and the short chain fatty acids have demonstrated the ability. So a few things the short chain fatty acids do with the brain. First, the blood-brain barrier is conceptually very similar to the gut barrier. It has the exact same proteins that are basically keeping the cells connected to one another, called the tight junctions. You mentioned them earlier, Jeff. These tight junctions, it's like, this is the fuse between them. And when they break down, you pop it open, and this is how you get, in the gut, that's how you get leaky gut. Well, there's an entire population of people who are suffering with brain fog, and they go to their doctor, and the doctor dismisses it. Like, they're like, oh, that's not real. Brain fog's not real. Well, tell me it's not real. These people feel it. Come on.
Yeah.
And I believe what's happening when a person has brain fog is that the tight junctions in the blood-brain barrier have been disrupted. And so now they have what I would call leaky brain. The short-chain fatty acids actually can repair those tight junctions and restore the competence of the blood-brain barrier. They can cross the blood-brain barrier and break down these beta amyloid plaques that are the precursors to the development of Alzheimer's disease that you're describing. And even, Jeff, in the study of Parkinson's disease, they now believe that Parkinson's disease originates in the gut. And what you will see in people with Parkinsonism is first, the manifestation of constipation. Now, to be clear, I don't want to scare people. There are a bazillion people with constipation out there, and a very small fraction of them will ultimately get Parkinson's disease. That being said, what they are finding is that people who develop Parkinson's disease will first manifest it in the gut with constipation, and then subsequently manifest it neurologically with the Parkinson's disease.
Wow.
It's fascinating.
That is insane. Yeah. Okay. I want to talk a little bit about some of the primary contributors to dysbiosis and intestinal permeability. We talked a little bit about the foods that promote a healthy gut, such as fiber and polyphenols and resistant starches. But what are the villains in this caper as far as it pertains to our microbes?
I first, before we even jump into this, I do feel compelled to say that there is a difference between consuming something in moderation versus like flooding your body with it.
Right.
And I do believe that. So the reason I say that is that I do believe that there are many forms of a healthy diet, not just one form. But when you look at it, all forms of a healthy diet, if we're like being serious about the research, there's a pattern. They're all predominantly plant-based. They could be plant exclusive, but they don't have to be. They could be predominantly plant-based. The Mediterranean diet is an example of a predominantly plant-based diet. And there's just no doubt that that's a healthy diet. So now, with that being said, we have a problem in the United States. 60% of our calories are coming from ultra-processed foods. It's not just the removal of the fiber. There are literally 10,000 food additives that have been stirred together with what originates as a whole food. It starts off as a whole food. And then we disrupt and we slice and we dice and we mix and we throw chemicals in there. And we end up with this thing at the end that's like an Oreo. And the Oreo gets packaged up and it sits on the shelf. And 2 years later, I come along and I buy a package of Oreos one day because I'm just like, YOLO, what the heck? I just want some Oreos, right? And it's 2 years later and I buy this package and it's as fresh as it was the day that it was produced. What's going on there? Well, I think people need to understand, we need to open up our minds to the reality that food has a life cycle. It's supposed to have a life cycle. It's not supposed to be perpetually the same. And what happens during this life cycle is that food, let's call it a plant. The plant starts as a seed. It germinates. It comes to life. It sprouts. That sprout reaches up through the dirt up towards the sun, and it grows and it matures. And one day, Jeff and I are walking through his garden, and I look down and I go, Jeff, there's a beautiful cabbage right there. We can make some sauerkraut. Now, we'll come back to that in a moment, but let's pretend that we don't make sauerkraut and we continue on our walk. That cabbage will continue to mature, and at some point, it will brown and it will start to decompose, and we could call it rotting, but that's kind of unnecessary. This is just the earth taking it back, and it's turning into soil. And that soil nourishes the next seed that falls down into it so that it can have a healthy life. This is the circle of life, right? And so, but microbes are a part of every single step that I just described. The seed has a microbiome. The sprout has a microbiome. The cabbage has a microbiome, to the point that if we harvested that cabbage and made sauerkraut, Jeff, all we would need is cabbage, salt, and water. That's it. And in 7 days, we would have sauerkraut, because the microbes that we need to inoculate the sauerkraut are already on the leaf. They're already there.
Yeah.
So, and the decomposition of the food involves microbes. So how do we prevent the decomposition of food? What do? We destroy the microbes. We keep the microbes out. If you keep the microbes out, then the food does not decompose. And this is what we see with the bread that sits on the shelf for 3 weeks and it's still soft and it's not moldy. And this is what we see with the Oreo that sits in the wrapper for 2 years and it's completely unchanged. And what does that mean when food that was designed to keep the microbes out comes into contact with 38 trillion microbes teeming inside your colon?
Yeah.
It's a problem. And that's 60% of our diet. Mm-hmm. And on the flip side, animal products, meat, dairy, eggs. Look, again, there are many forms of a healthy diet, and some of those forms include some animal products. But in the United States right now, the average person is consuming their body weight plus another 50 pounds of animal products per year. And that's an obscene amount of food. And so when we're flooding our body with something that is not only devoid of fiber, but very high in saturated fat, and the saturated fat appears to disturb the gut microbiome and cause the arrival of inflammatory microbes. Like an example is Bilophila wadsworthia, that will arrive within 5 days of changing towards more animal products in our diet. And Bilophila wadsworthia has been associated with the development of ulcerative colitis. Or within 5 days of eating more animal products, we'll see the arrival of Bacteroides species associated with colorectal cancer. Or Allostypes putridenus, again, associated with colorectal cancer or abscesses. So we're not getting the value, we're not getting the short chain fatty acids when we consume our body weight plus 50 pounds of meat on a yearly basis. What we're doing is we're crowding out the plate and we're missing out on the opportunity to eat the food that's healing us. And so if I were to describe from a purely nutritional perspective, the two main concerns, it's this balance. We have a scale, and we could load up the scale with the fiber-rich foods from fruits, vegetables, whole grains, seeds, nuts, and legumes, and reap the rewards through the production of short-chain fatty acids that come from that. But right now, that's not what we're doing. Right now, we have none of that. And 90% of our calories are ultra-processed foods and meat and animal products. And this is a balance that is frankly unsustainable when it comes to our gut microbiome.
Yeah, and I think, I appreciate your kind of non-dogmatic, non-fundamentalist approach to diet. I think it's very open-minded and cool-headed, because it's a topic that can generate a lot of invective, if you will. And, but if you do look at some of the diets that do include meat, for example, in some of the blue zones, for example, where there's the highest concentration of centenarians, meat is generally treated as something of a specialty or something that flavors a meal. And the meat
Right.
that is consumed has been feeding on like xenohormetic plants and plants that are full of polyphenols and
Right.
so if you have go to Sardinia or Icaria, Greece or something, and you have some lamb, that that particular animal was raised eating regeneratively grown or organically grown plants. Now, of course, they don't really call that regenerative agriculture there; they just call it the agriculture that's growing. But
Right.
but it's a
It's just
complete
a mountain. It's a mountain with some grass.
yeah, exactly. Um, but that is a very, very different kind of situation that's happening, day in and day out here, as you outline with the industrial meat industry, and where you've got millions of cattle on a CAFO, et cetera, getting filled with antibiotics and force-fed grain. And of course, we're downstream from that. And of course, then we ingest those same antibiotics and our microbes have to deal with them. So it's
This is this is
yeah.
actually a very important point, Jeff. So I just want to I apologize for interjecting, but I just want to point out a quick study that I've been alluding to, where it's actually from Nature, published in 2014 by Lawrence David. All right, and basically they did 5 days on a completely plant-based diet versus 5 days on an animal-based diet, and the goal was to see, like, can we change a person's microbiome with food? And the answer was yes. Within 24 hours, there was already a change within the gut microbiome. They would check the microbiome every single day. But on the plant-based diet, more of the anti-inflammatory probiotic microbes and more short-chain fatty acids was the reward that you get. But on the flip side, again, a completely animal-based diet, so just meat, dairy, and eggs, zero fiber. So on this diet, we talked about the microbes that are associated with ulcerative colitis, with colon cancer. But one of the surprise findings that you're alluding to, Jeff, is that they actually discovered that within 5 days, those people already had antibiotic resistance within their gut microbiome.
Wow.
Now, this is very disturbing. And where does it come from? Well, meat is not inherently going to produce antibiotic resistance. You eat the lamb in Sardinia, you're not going to do that. But when you pump these animals up with antibiotics, which, by the way, in the United States is a common practice in animal agriculture, 80% of the antibiotics in the United States are not given to humans. They're given to animals. And it's because when you give, for example, a pig antibiotics, it will gain 15% more weight, even though you feed it the same amount of grain. And so if I am the CEO of a pork company, that's a win. I'll take 15% more pounds of meat, but their responsibility is not human health or public health. And we're seeing a disaster because antibiotic resistance is something that if you and I don't have to deal with this, Jeff, my kids will have to deal with it. And I'm not happy about that.
No, nobody should be. And of course, what you're referring to is that the animals that we're eating are themselves in dysbiosis. Most likely they have leaky gut. So they are in 100%. A state of chronic inflammation. So what's happening? They're experiencing all of these, diseases that are downstream from inflammation. And that's what so many people are eating. And then if you go even upstream from there, well, what are they eating? Well, they're eating things that they're not evolved to eat. I mean, cattle, for example, have been evolved to eat grass, but they're being force-fed grains, which are then GMO engineered, where all of the significant nutrients have been chelated, and so these are unhealthy animals that populate, most of the food supply, and it's just it's just not tenable. And, if we put our hands up in the air and we wonder why we have a $4 trillion pharmaceutical industry, and, that prescribes, statins and all of these other, pharmaceuticals every day. And it's because, we're just not eating a diet that's healthful. And it's just that simple.
It makes complete sense. And, we look at Costa Rica, which is where one of the blue zones is.
Right.
And this is a country where they spend 1/15 as much on healthcare per person compared to us. Like, one person's healthcare in the United States could fund healthcare for 15 people in Costa Rica, and they are living just as long as we are, if not longer. We spend way more than anyone in the world on healthcare, and we are like ranked number 41st in expectancy.
Yeah, and it's going down. Even pre-COVID, our life expectancy is going down. And of course, COVID, but even pre-COVID, what we're seeing is this bifurcation too, which is, we've got this, relatively small class of people that have access to really, really great food and are, doing things like wearing continuous glucose monitors, et cetera. And then you have, a huge cohort of the population that are living in food deserts and suffering from just unfathomable rates of, diabetes and chronic disease. So, eventually this is going to impact everybody.
Oh, it totally does. We will, because we'll all pay the price for it with our healthcare expenses, which we already are. But like, I don't want to see any of my fellow humans be suffering with diseases that they don't need to have. Right. I mean, I there's not a person that I would wish that upon out there, even my mortal enemy. But, one of the issues, Jeff, is that I want to make sure that people understand that the backbone of a healthful diet is not the fresh produce at Whole Foods. The backbone of a healthful diet is actually beans and whole grains. Yeah. And these are not expensive foods. You could get pounds of beans for the cost of 1 pound of most forms of meat and nourish your body and reduce your risk of heart disease and cancer and live a longer life. These are longevity foods. And when you look across the 5 blue zones, you find that for all 5, really, truly, the backbone of their diet ends up being some form of legumes and whole grains. It varies, right? Like, it could be rice and black beans in Costa Rica. And, it could be farro and some pinto beans in Sardinia. But in all of these places, that's what they're eating. And so the other thing that I would add is, if people are not sprouting, you should be. Yeah. Sprouting is incredible. It's you are eating the most nutritious, freshest food. You know exactly how it was sourced because you're the one who grew it. It's like having a garden on your kitchen counter. And speaking to sustainability and access, you could buy organic lentils. They are not expensive. And take a half of a cup of organic lentils and sprout them for 3 days. And you have 4 cups of sprouted lentils. And good luck trying to eat that in one day. Right. And so I think it's important for people to understand, there are versions. A lot of this is education. This is what I'm here to do.
Yeah.
A lot of this is education so that people understand it's not the fresh salad that is the backbone of a healthy diet. It's the legumes, it's the whole grains. And when you want fresh food, you could do it incredibly inexpensively on your own counter by sprouting legumes and seeds.
Yeah, you're actually the one that got me into broccoli sprouts, which from a phytonutrients profile perspective are like 1,000 times more nutrient dense than broccoli itself, and they're delicious, and they've got this like nuttiness to them, and it's amazing. And I think that that point is really well taken, is that it doesn't have to be a whole foods diet. In fact, lentils, chickpeas, split peas, brown rice, seeds like chia and flax, and all of this stuff is beautifully outlined in your new book, the Fiber Fueled Cookbook, that's coming out in May. And I've just started to go through some of my favorite recipes in there. And I will say that the photography in the book is stunning, and it points to, it sounds kind of cliche, but it points to that diversity of the rainbow, right? And it's the eggplant hummus Buddha bowls and the sesame broccoli noodles and some of these recipes that you have in there. They're just they're beautiful to look at. They're so much fun to make, and you get the added benefit of them actually being really good for you. But I think that point that you make around the affordability is great.
Yeah, I'm very excited about the Fiber Fueled Cookbook. I'm getting the same feeling that I had before Fiber Fueled came out, which is that I feel like there's this powerful message that the world needs to hear. And it's like you said in the beginning, Jeff, right now I'm the only one who knows anything about what's really in there. I mean, you've seen the preview of the book, but like largely the world hasn't heard this message yet. And I think it's going to change people's lives, because what I'm excited about here is not just that it's a cookbook. It is a cookbook, 125 recipes. The recipes are by Alex Caspero, who's a registered dietitian. She did the recipes for my first book. The photography is by Ashley McLaughlin, who has done photography for New York Times bestselling cookbooks. But really, this to me is I'm a doctor, and a book is an opportunity for me to apply my education and experience in a way that improves a person's health. And it's very exciting because that's what I'm hearing from you happened when you read Fiber Fueled. And I sincerely believe that this is what's going to happen for a lot of people with the Fiber Fueled Cookbook, because this is a toolkit for optimal gut health. No matter who you are and where you're coming from, let me teach you how to eat food that's delicious and also great for your gut and will nourish and support a wide variety of those gut microbes. Let me teach you how to sprout. Let me teach you how to ferment. Fermentation is fantastic for the gut microbiome. And if you suffer with food intolerances, I actually wrote literally an entire book. That's like, basically this is a book combined with a cookbook. And I break down how to approach food intolerances so that you can not just know what's causing trouble, but you can actually overcome them and restore functionality to your gut. So what I'm excited about here is that I feel like for the first time, no matter who you are, whether you do or do not have digestive issues, whether you are or not plant-based, we have a common space that we can all come together and find great joy in food. And that to me is part of what brings us together and is one of the sort of essences of the human experience, is sitting at a table with people that we care about and having great conversation and eating food that really warms our belly and brings us great joy. And that's what I'm hoping people find in the Fiber Fueled Cookbook.
I'm absolutely confident that they will. And, you speak to community. Obviously, in community, we pass bacteria back and forth. So that's one of the benefits to it. But there's also an element of community that's being studied now called sociogenomics, where when we're in connection with each other, we're actually upregulating each other's gene expression. And we talk about kind of epigenome and, how DNA is transcribed, et cetera. But actually, we're learning that, this notion that that we find in the blue zones, for example, where community is really strong, there is an actual physiological dimension to that, and nothing brings people together like food.
Right.
When people are sitting around a table and able to really enjoy each other's company and dive deep into conversation and not be distracted, just to really be all there. That's really what makes life worthwhile in the first place. So I think you're giving us a great gift that helps us set that table.
I appreciate you saying that, Jeff. And I'll just add on to that we all eat. We have to eat. That's a part of sustaining life. The food that goes in our mouth comes into contact with these microbes. We might as well make dietary choices that support and nourish and enhance that microbiome so that it can be the best that it can be at doing its job, which includes the things that you're describing, like genomics, the expression of our genetic code. And I can assure you that if we looked under the hood of what you're describing, Jeff, we would discover that the gut microbiome is a part of that story. And just as a quick example, I know we're closing out here, but I can't help but slide this one in there at the last moment. They did a really interesting study looking at the shared microbes among married couples. And they discovered that this cohabitation where we exist together, we start to share our microbes, and it's not actually our dietary choices that predict that sharing. So there was something else that explained it. And here's where it gets really fun. They looked at the level of satisfaction that these couples had in their marriage. Some people are very optimistic and enthusiastic and happily married, and some people are not. And when they looked at it through that lens, they discovered that the people who were the most optimistic and happily married shared the most microbes together. Now, I don't know exactly how to interpret that. There's a lot of different angles that we could take, but there is no doubt that it is fascinating that in love, this is part of the reward, is we get to share microbes together.
That's amazing. Well, that is just a token for how much we still have to learn, and how, you have so much curiosity. And to be honest, so do I. When I have these kind of conversations, it just continues to light a fire under me to learn and to keep asking that question, why, and go deeper. And I just really enjoy it, and I enjoy your spirit so much. So, I would characterize the relationship with my wife as pretty optimistic. We've been together for 34 years. So maybe we need to go, have our microbiome analyzed and see what a good match we are.
Well, I think we know that we would find some very exciting and great things there.
Hey, I'm glad you enjoyed this video. We have conversations with today's top thought leaders every single week, so make sure you click the notification bell below so you don't miss our weekly videos. I'll see you soon.